Okay, let's start the next module on doing the computation. So first part was, hey, let's just process the data and download it, but let's understand how Earth Engine will actually do some data processing. Let's learn about spectral indices. First, one of the most commonly used operations in remote sensing is to compute an index. Just some basics of remote sensing. Here you have on the x-axis some bands of wavelengths, and on the y-axis is the reflectance. If you measure the reflectance of some material, let's go to vegetation. You go to a vegetation, you take a spectrometer, measure how the vegetation reflects light in different wavelengths, you'll get something like this. Healthy vegetation will have very high reflectance in infrared band. It'll absorb most of the red light, and that's how vegetation is. So if you want to detect healthy vegetation from your images, you'll say, I'll find all pixels where NIR is high, red is low. And you can see other materials don't follow the pattern. Most other materials will be having a different pattern. So to find that healthy vegetation, you can design an index where you can say, I have this image, I want to find healthy vegetation. I will say I will take the NIR and the red bands, take NIR band, divide by red. NIR value will be high, red will be low. So healthy vegetation will be very high as a ratio. Other will be very low, and I can select pixels which are high. This is called an index called NDVI, Normalized Difference Vegetation Index. If you just took the ratio NIR divided by red, you'll get arbitrary large or small values, right? You will say divide 0.3 by 0.01. You'll get some very large value. So to constrain your values to a range, you can do this normalized difference. If you say NIR minus red divided by NIR plus red, you'll always have values between -1 to +1. It also makes your results more interpretable. You have some sense of what does 0.5 mean, and what does -0.5 mean. So most of the remote sensing indices would take form of this normalized ratio of two bands. Similarly, if you go for water, you can see the water has high reflectance in green band, has lower reflectance in all the infrared bands. So you can design an index, which is the ratio of the green and NIR band, to detect water. So that is an index called NDWI, Normalized Difference Water Index. And if you do this, suddenly you will see all pixels which are water, which will have very high value. And you can use that to detect water. There is also NDBI, built-up index. Built-up surfaces will have high reflectance in short-wave infrared. So like built-up surface like concrete, will have like high values in SWIR band, low values in NIR band. So you take the ratio, you suddenly see all the built-up regions. Right? Again, there are a lot of indices depending on the material that you want to detect. You can do an index. So let's learn how to compute an index in Earth Engine. We'll first learn how to compute index for one image, and then we'll say, let's compute index for every image in a region for past 10 years or something. Right? We'll learn, but first let's see how we can implement this. Let's start part 2. Okay, let's see the code. We'll come back to our AOI, but right now we just say I have one point here, and we filter all images for 1 year here, and I just want to work with single image, just to show you that I just want to show you how we can compute an index for one image. So I want to extract one image out of my collection. I can also sort it. So I say I have this images collected throughout the year. Let's sort it by some property. So here I'm sorting it by this property called cloudy pixel percentage. That means the lowest cloudy pixel percentage will be at the bottom and higher will be higher. So we can say I want the first image, which will be the least cloudy image, over this point in that 1 year. Right? This is one way to just say I want to sort it and get the least cloud image for this region, and I can just display this. So I found this one image. This is a single Sentinel-2 scene over in 2019 over the city, and this is the least cloud image. It's not completely cloud-free, but it's the least amount of cloud that we have. Let's say I want to compute an index for this. Let's learn So we saw that NDVI is the ratio of the NIR and the red band. Let's compute that. Since this is a very common operation, Earth Engine provides you with an API function to compute an index. The API function is called normalized difference. So you take an image and run this function called normalized difference, give it a list of 2 bands, you're going to get the ratio of those 2 bands in Earth Engine. So let's say I want the ratio of 8 and band 4. That's it. NDVI is calculated. Let's visualize this. So to visualize this, I need some visualization parameters. So I will create some vis parameters. What should be the min and max here? For -1 and 1. When you have one band image, so this is just a single band image, right? One band of information. You can colorize your image by giving it a palette. So I have this range of values. By default, it will be in shade of gray. So low values will be black, high values will be white. Instead, I can say I want to display this from white to green. When you do this, -1 will become white, +1 will become green, and if your value is 0.5, it will just interpolate to a shade of that. Even though the theoretical min-max of NDVI is -1 to +1, if you're in an urban region like this, most pixels will be between like 0 and 0.8. Right? If you're working in a forest or a region, you might have a different range. So if you want a kind of good visualization, maybe I would visualize this with 0 to 0.8. And again, you can get this by experience, or you can do the stretch. Once you display this, you can do the stretch and say what is the 98th percentile value range. But let's just display it between this. So I'll say map.add layer, NDVI, NDVI viz. And you have an NDVI image. Let's zoom into some region. I can inspect a pixel. So this is a park in the city of Bangalore. If I inspect this region, you can see the NDVI value is 0.58. Pretty high value, NDVI, right? So that's a tree, that's a healthy vegetation. Look at this white part. You can see in the RGB image, both look green. This is a lake, which looks green in the visual range. But this is water. If you look at the NDVI for this, very low, because it's water, it's not vegetation. So if I inspect a water value, okay, so it's negative 0.15. Right? So even though in RGB band it might look green, if you do NDVI, you can differentiate between those different objects. That's why indexes are very useful to detect a certain kind of object here. So we have this NDVI visualized here, and we can use this for our analysis. Questions on NDVI? Okay, let's do another one. I'll do NDWI. So NDWI historically was green and NIR band. This was developed in the early days of Landsat, where we had only RGB and near infrared band. But if you see the SWIR bands have even lower reflectance for water. So once the new sensors, all of the new sensors include a SWIR band. So there's a new index called modified NDWI, which is not green and NIR, but green and SWIR. This gives you even better results. So if your data set has a shortwave infrared band, use that, and you can develop this index called NDWI. So let's implement this. Image normalized difference. We'll do band 3 and band. And we can just copy this code, just change it. I'll do white to blue. So you can now see the same region looks very different in a different index. Right? This was NDVI, this is NDWI. If I inspect the water pixel here, you'll see that NDVI is very low, NDWI is very high because it's water. So you can now use this index to detect water bodies. One of the stuff you'll see is when you run this function, normalized difference, Earth Engine will create a new image where the name of the band is ND. ND stands for normalized difference. So you can see both the bands are called ND. Because whenever you run this function, Earth Engine will give you a new image with this band called ND. So instead, I will say, I want more descriptive names. So you can also use this function rename, and you can rename the band that comes out of this. So now when I inspect this, you'll see that my bands are now called whatever I named it. Right? So I just renamed my bands to be more descriptive. So if I want to combine them, I know what they are. Yes?
So in this case, NDWI is an image, and you would not be able to do like band math with it, basically. You would get an error back if you were to try to do the same operation with two images.
Why would you get?
Because it's not added to a collection.
No, it's fine. You can do band math is done on images. You can say NDWI plus NDVI, you can add that.
Would you be able to run a function off of that as well?
Any function that runs on images, you can run that.
And you can make a collection from individual images as
Yeah,
well.
but most functions in Earth Engine will still require an image. So if you say I want some statistics, the statistical functions run on images, not on image collections. So whatever functions run on images, you'll be able to run on this.
I've had errors where I don't know which functions, but where they required bands as a part of a collection.
So let's say you cannot run a filter here.
Yeah.
Because filters would work on image collections, right? Filters say I want to select an images with certain criteria. I just have an image. It won't work here. So again, depends on what you want to do. It depends on the.
Yeah, but so maybe just kind of following up your example, for instance, right? So he does an MNDWI. You could map that across the full collection. The output would then itself be a collection. And so then you could do further things on that collection versus like just pulling out one image.
.map function?
Yeah, .map is coming up next. It's that second script here. So some of your indices will not be a simple ratio. So maybe you are trying to implement an index, which is some equation. So let's say we want to implement this index called Savvy, where the formula is not NIR divided by red, it's just 1.5 times this divided by this plus this, right? You cannot use normalized difference. If you have an index that has more complex formula, Earth Engine has this function called expression, where you can implement arbitrary expressions, any complicated formula, and do some computation. Let's see how to do this. We'll say image.expression. Let's look at the docs. The expression function takes two parameters. The first one is your formula. It's just a formula that you want to implement. Second one is a dictionary of the parameters that you want to specify. Let's see here. So first, I will say this is my formula. So I have my formula. And the second parameter is a dictionary saying, what does NIR mean in this context? What is NIR? And I say NIR is my band 8. So wherever you see NIR in this formula, replace it with the value of band 8 from my image. And say what is red here, and say image dot. Red will be 4. And thank you. Here in the formula, NIR doesn't mean anything. You can just do x minus y. x plus y plus 0.5, and you have to say what is x, and you say x is this, y is this, right? You can write your formula in any way you want, and then say wherever you see this variable, replace it with the value of the different bands, and I can display this. One problem though, if you read the paper that invented Savvy, this says the x, y here has to be reflectances of NIR and red bands. Do we have reflectances here? Is the band 8 reflectance? It is meant to be, but it's not yet. It's like values are 2000, 3000, right? You have to multiply it by this 0.001 to get the reflectance. We didn't have to do this elsewhere. Even NDVI says the ratio of the reflectance. But when you take the ratio of 2000 by 3000 or 0.2 by 0.3, it's the same because they cancel out. But when you're implementing a formula which expects a reflectance, we'll have to convert this into reflectance values. Let's go to the dataset description page. You can see there's a scale value. Each of those bands has to be multiplied by the scale value to be getting the reflectance. So now we have our Savvy. Let's just visualize this. I'll use the same as NDVI parameters. And you can see you have some Savvy value. You can also rename it if you want. So again, two different ways of doing indices: normalized difference for a simple ratio, image.expression for any complicated formula that you can use. Yes?
So would it be different if we used divide instead of multiply? Would be any difference for the server or for the time?
Divide by 10,000, right? Yes. Same thing.
But
Multiply.
it wouldn't be different for the server, for the process that we don't
No.
see. Okay.
As long as you are using the API functions, the server is quite resistant to, it can kind of manage that. A lot of times people ask, does it matter if I do this filter first or second filter first? It's usually the same. So, but make sure you're using the server-side functions, like multiply. If you just do star this, it may not work. Okay, let's do the exercise 1C in part 2. Delete the geometry, drop a point at your chosen location. It'll load the least cloud-free image, and then we are already loading the image, and you want to compute this index, NDBI, normalized difference built-up index. This is the formula. Go and implement this. Feel free to copy the code from 1B. So you can copy this and change stuff. You don't have to remember the syntax. The SWR bands, so SWR 1 is band 11, and NIR is band 8. We are in part 2, exercise 1C. Delete the geometry, drop a point, run the code first, you'll see the image, and then implement the NDBI.
Just to mention too that like one of the things that you saw Ujjwal is also doing is he has Earth Engine running in multiple tabs, which allows you to then move between one tab and the other without having to, say, lose what is in one script.
Yeah, one of the top feature requests for code editor is, can we have tabs here inside? And every time I meet somebody from the Earth Engine engineering team, I say, please implement tabs here. Otherwise, this is kind of cumbersome. So if you meet an engineer, tell them, please implement tabs. Just get some water.
You're saving the world.
Yes. Here's the solution on the screen. If you're trying to type this in, make sure you use the autocomplete. Type normal and then press control space to autocomplete the function name. Or you can just copy paste from the previous script and change the band names. So one tip, when you're visualizing all these one-band images, you need to give palettes. You can give simple colors like this, but if you want a nice visualization, I recommend using this site called Color Brewer. Anybody's used this site before? Yeah, it's a great site. I use it even for QGIS and Python. I get my colors from here. Let's say you want to have a nice red palette. You can select a number of classes that you want. Select the palette. If you like this, you can say export, and you have a list of colors in JavaScript. And I can take this and say, instead of white to red, I'm going to create this fancy palette, and my map will look much better. Right? So again, use Color Brewer to get your color palettes from here.
I think they also have red-green colorblind support.
Yeah. So you can get a color bright and friendly palette as well. Also for mapping, I actually use QGIS, and QGIS also has a preview. You can simulate various kind of color blindness to see how your map would look to different people. So I typically, before publishing the map, just test this out. So make sure it is superior. Okay, done. Any problems with NDBI?